global warming is real and we're causing it, and your mom and dad are not certain about that, I say your teachers have my email address, and please have mom or dad write to me, and we can talk about it a little bit further. But, well, I would like to thank my station, Denver 7, for allowing me to do this. There are, as we know, some groups out there that discourage their on-air people from discussing this topic, and my bosses have been very gracious about this, and they understand the importance of it. So without further ado, we have a really good group of speakers tonight, and we're going to focus on the science, but also the solutions, because people say it's not settled. No, the thermodynamics have been settled going back to Isaac Newton. We know how a lot of these things work, and we certainly knew it from the 19th century. The political science may not be settled, and certainly the science of the solutions is not settled. But we're going to discuss quite a bit of that tonight. So I'd like to get started right away. One of the people that I've learned more about climate science probably since going back to college is right here along the Front Range. Well, I have a question that I can't answer, which does happen occasionally when somebody that is relatively educated, a physicist or somebody will write to me. I always defer to this gentleman, and he's very, very gracious with his time, and he's really good at explaining it. So without further ado, I would like to introduce from Colorado State University, go Rammies, Professor Scott Denning.
Good evening. Really delighted to be here. I got 3 things to talk about with you in the next 10 minutes. All 3 of them start with the letter S, so it's really easy to remember. The 3 S's of climate change are simple, serious, and solvable. And I always do all 3 S's. Everybody's heard about that middle one. You got to talk about it. Sorry, you know, it's no fun. But I try to make a sandwich here. And so simple is how it works, serious is why it's bad, solvable is what are you going to do about it. You might ask, how could somebody like me call it simple? I've been working on this for like 30 years. How come I still got a job if it's so simple? But let me start with this. Do you ever wonder why day is warmer than night? Do you ever wonder why summer is warmer than winter? Or why Phoenix is warmer than Fargo? I know you already know the answers to these questions, but think about it just for a second. It turns out the answer to all 3 questions is the same. It's because heat in minus heat out equals change of heat. Okay, it's not that hard to understand. This is something you learned in the 5th grade or something. Now, I don't know if you guys remember last week, it was 78 degrees on Tuesday and then it snowed on Wednesday. That's heat coming in and out the sides, okay? That's what Mike works on, that's the weather. But when you look at the whole world, there are no sides. The Earth is round. So you can move the heat all you want sideways, it doesn't change the total amount of heat in the Earth. The only way that you can change the heat for the whole planet is through the top. Now you're not used to thinking of the Earth as having a top, but it does. We call it the top of the atmosphere. And heat comes in to the top. But, you know, everybody knows where that heat comes from, right? Where's the heat come from to warm the Earth? From the sun. But that's just heat in. And heat in minus heat out equals change of heat. So if that was the whole story, that's just heat in, heat in, heat in. You know, it's going to get hotter and hotter and hotter until it like melts and boils and vaporizes the end of the world. So clearly that hasn't happened. So there's got to be heat going back out. And the heat going back out, unlike the heat coming in, you can't see that heat going out because it's infrared heat, infrared radiation that doesn't have the right wavelengths to tickle our retina at the back of our eyes, and so we can't see it. But if you slow down the heat going out, then heat in is greater than heat out, and you warm up. And that's basically how the climate works. Now, the heat out has to pass through the air, and the air is made of molecules, and 99% of the molecules in the air are just these 2 kinds. Oxygen, you're familiar with that one. If you aren't, just hold your breath for a minute or so. And nitrogen is the other one. But these 2 molecules are 99% of the air, and they're diatomic molecules. They got 2 atoms of the same element glommed together with shared electrons. Never mind. Anyway, along comes this electromagnetic field, which is the infrared radiation cooling the Earth, passes through these molecules, and it tries to lock onto those bars there, the charged particles. But because they're 2 atoms of the same element, The only thing they can do is to get longer and shorter, like woo, 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 woo. Doesn't really make that sound. I just make that part up. But the woo-woo thing is an excited molecule, and that molecule can then release a photon of the same energy level and de-excite, woo, 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 whoa, 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 back to its ground state. But because 99% of the molecules in the atmosphere have just these two atoms of the same element, that's the only dance they know, the only way they can wiggle. Now, a very small number of molecules in the atmosphere have 3 atoms instead of 2 atoms. And by far the most common elements or molecules in the atmosphere with 3 atoms instead of 2 are these two, carbon dioxide and water vapor. Now, only got the 2 hands, so let's let this be carbon, oxygen, oxygen. Now I'm a CO2 molecule. Along comes infrared radiation, woo, 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 whoa, whoa, whoa. But there's more. Because unlike O2 and N2, the CO2 molecule can go each one of these ways a wiggle in that molecule will absorb a slightly different wavelength of infrared radiation, a slightly different energy level of infrared photon. That's what makes CO2 a greenhouse gas. It's not greed or capitalism or Al Gore. It's just bad luck that the stuff that comes out when you set carbon on fire's got 3 atoms instead of 2 atoms. So we say it has a rich absorption spectrum that absorbs a lot of infrared and doesn't let it get back out to space. You've all seen the cartoon before, right? The sun beats on the earth, some of it reflects off. The stuff that doesn't get reflected off is heat in. That's got to be matched by heat out. The red arrows indicate the infrared. A little bit of it does get out, about 6% of it. But most of it gets stuck in the Earth system by interacting with these molecules or with water droplets in the atmosphere. I have in my office a radiation measurer thing that if you point it up at the sky at night, you don't get any sun radiation down, but you still get lots of heat radiation coming down at night from all these molecules in the sky. In fact, without that downward radiation from the atmosphere, our Earth would be frozen solid. We wouldn't be here talking about it. So it brings me to what I call the common sense explanation of climate change. Many of you are old enough to remember these. This is an incandescent light bulb. So, you know, back when I was a kid, these things were Christmas tree lights. And then when my kids were little, they were night lights, you know, in the hallway to let them find a bathroom. That's a 4-watt light bulb. And if you double the number of these beep, boop molecules up in the sky, it would add this much extra heat to every square meter of the world. Now, I don't know, a couple of these chairs down here is about a square meter, so you can imagine a light bulb there and there and there, there. Wouldn't just be this room, though. Wouldn't just be Colorado. It'd be the whole planet covered with 4-watt light bulbs every 3 feet. Now, if you did that, the world would be a little bit warmer. You know, maybe not a lot warmer because there are only 4-watt light bulbs, but there's a lot of them, right, every 3 feet. And you're going to leave those light bulbs on 24 hours a day, 7 days a week for the rest of your life. Believe it or not, all of that was known before light bulbs were invented. This was originally discovered and described and quantified in the 1860s. When Abraham Lincoln was president, people put CO2 in flasks and shined infrared light through them and measured how much absorption there was. Now, it's been 160 years. Instruments have gotten better and better and better, but we all get the same answers. We've done it from outdoors and from airplanes and from satellites, and there's really no wiggle room. The CO2 really does absorb the outgoing heat from the Earth, and adding heat to things really does warm them up. It brings me to what I call common myth number 1. Now, it's dangerous to tell you a myth because you're going to remember the myth. Okay, so warning, I'm going to tell you something that's not true. Okay, the thing that's not true is that the reason scientists expect it to get warm in the future is because it's been getting warm lately. And it's true, it's been getting warm lately, right? It got warmer and then it got warmer faster. And this is not how we figured out global warming. You kind of get the idea that it got warm and then people wonder what the heck's going on? Why did it happen? And they looked at the CO2 and that's been going up too and they're doing some sort of correlation. But that's not it. The reason we know CO2 will warm the climate is because we know that when you add heat to things, they change their temperature. Okay? This is how a pot of water warms up on your stove. This is called the first law of thermodynamics. You know, adding heat to things causes change in temperature. But you got to be some sort of egotistical Victorian Brit to call something that simple the first law of thermodynamics. And for God's sake, cavemen knew that, right? They put the mammoth on the fire and it got hot. But they didn't say first law of thermodynamics, they said, ugh, hot. So this is the story of climate change, and everybody can understand this. Now I got to talk about the serious part, and you guys are going to not like me for saying these things, but it's just the way it goes. If this doesn't get addressed, it becomes the most serious problem in the world. How much warmer are we talking about? Well, it depends. If you burn less, you don't get as much warming. If you burn a lot, you get a lot more warming. But it's not the same everywhere. The land warms up way more than the oceans because the oceans are deep. The oceans are 13,000 feet deep, and little 4-watt light bulbs on 13,000 feet of water doesn't do that much. The other thing you might notice is that the southern hemisphere doesn't warm up as much as the northern hemisphere. That's because the southern hemisphere is mostly water, and the northern hemisphere is mostly land. And the third thing you might notice if you look at the maps is that the snowy places warm up more than the not snowy places, and that's because snow is bright and white and reflects sun to space. And if you warm it up a little bit and you melt the snow, you soak up some extra sun, and that adds compared to the 4 watts you were getting from the CO2. So, you know anybody who lives on land in the northern hemisphere where it snows? With a low amount of emissions, we might get 3 Celsius. With the high emissions, we might get 6 C. But actually, we live in a place that uses Fahrenheit. So converting those Celsius degrees to Fahrenheit degrees, that's more like 5 or 10 degrees here. And 10 degrees, I don't know, it's like 45 today. If it was 55, you'd probably be okay with that. We're not just talking about today. We're talking about on the average. Now, here in Colorado, the best way to think about average temperature is with elevation, right? You guys know about this. You got the foothills where the ponderosas are, and the higher mountains where the lodgepole, and then up to the snow and ice and tundra and stuff. 10 degrees of Fahrenheit of warming is equal to about 3,000 feet of vertical climb. So 10 degrees Fahrenheit of warming in Estes Park makes it as warm as Denver, and makes Trail Ridge Road as warm as Estes Park. That's actually quite a lot. You would absolutely notice that. Here in the West, we think of this as a water issue. That's a map of average precipitation in the western U.S., and 75 million people live where in that part of the map. The reason we can get away with 75 million people living there is because of those green places on the map. You know what those are called? Mountains. And the snow falls on the mountains, and it melts this time of year and runs down to make our water supply. So warming us up by 3,000 vertical feet is going to put a serious dent in that water supply. Now, drought is not just about water supply, it's also about water demand. And if you warmed us up by 10 degrees Fahrenheit on the average, we would use a lot more water. I'm going to skip some stuff here because it's depressing. Go on to solvable, because, we need to talk about this third S, and Mike gave me the high sign. So what do we got to do to avoid bad consequences from climate change? There's one simple thing that we have to do. Stop setting stuff on fire. In order to do that, there's sort of two parts. One is to use less energy for the stuff that we do, and two is to make energy that doesn't involve setting stuff on fire. It turns out the most energy-intensive thing that we do is build and operate buildings. Now, these are graphs. Sorry, graphs are complicated. The U.S. Department of Energy expected that by 2030 we'd use a whole bunch more energy in buildings. That's a prediction that they made in 2005. You can see they made the same prediction in 07 and 09 and so forth. What's happened here is that architects have gotten a lot smarter about buildings, and we got better lights and windows and doors and AC and all that stuff. And just this one change alone, besides saving vast amounts of energy, will save you $4.5 trillion between now and 2030 because it's energy that we would have wasted. The other thing, of course, is that the price of generating electricity without setting stuff on fire has come down dramatically. The year I graduated high school was 1977. In the year I graduated high school, solar panels cost $77 a watt. Okay, solar panels are now under 40 cents a watt, 200 times cheaper than when I was in high school. Imagine if, like, cars were 200 times cheaper than when I was in high school. I mean, it's amazing what's happened here. Now, it is going to cost a lot of money. Yes, there's a toilet on here. No, that is not a suggestion. Economists estimate that it's going to cost in the neighborhood of 1% of the global economy to switch the entire world off of fossil fuels. Now, 1% of the global economy is a boatload of money, okay? Total value of all goods and services sold in a year in the world is about $80 trillion a year. 1% of that is $800 billion a year. That's more than the US defense budget. But it's roughly in the neighborhood of what it cost 100 years ago to retrofit all the world's cities with indoor plumbing. Think about the labor alone of digging up every street in New York and London and Paris and laying sewer pipes, and knocking out tenement walls 20 stories high and putting in hot and cold running water, and knocking out all the flats, partitions inside and putting in toilets and sinks and showers. And boy, are we glad they did that. But think what it did for plumbers. Think what it did for plumbing suppliers. Think what it did for the grocery store down the street from the plumber, or the children of that plumber who could go to college. These are my grandparents. That's Max and that's Francis, and it was their generation that invested 1% of the world economy on indoor plumbing. And when they were done with indoor plumbing, they did rural electrification. They ran separate little freaking copper wires to every house in Nebraska and Kansas. Imagine what that cost. When they were done with that, they did subways and fought that. I mean, not my grandparents personally, but you know. These are my parents. That's Margie and that's Bob. And their generation did it too. They spent 1% of the world economy building the interstate highway system. And they fought the Cold War. They sent people to the moon, for goodness sakes. Really, really big things. And none of those great big 1% of the world economy projects bankrupted the world. This is my wife and I back when I had hair. And our generation spent 1% of the world economy on putting a computer on every desk in every office on Earth. And when we were done with that, we bought cell phones for everybody, or built them for everybody and sold them. And we built the internet. All of those are 1% of the world economy projects, and not a one of them made us broke. These are the projects that produced all the economic growth in my adult lifetime. These are my kids, and they get to do it again. They get to replace perfectly serviceable old infrastructure that's destroying the economy and destroying the world with new stuff that works better. And that's going to produce all of the economic growth and all of the jobs during their lifetimes as well. Here's two different ways for you to think about history. One way says, we get our way of life out of the ground. There's value in a lump of coal, and you'd sell it to somebody and they set it on fire, and they sell the energy for a profit to somebody who makes products and services for a profit, and you wheel and deal, and pretty soon you got yourself an $80 trillion a year global economy. And maybe that is how history works, but God, I hope not. Because if that's really the case, then when you either run out of this stuff or decide to stop burning it, you go back to shivering in the dark. What a grim way of looking at the future. I prefer this other way, that we make our world, that it comes from in here, from creativity and ingenuity and hard work, not from the ground, but from the sweat of your brow and the spark in your soul. And we're not running out of those things, and the kids are going to be okay. Thank you for your time.
Thank you so much, Scott. You can see why I enjoy listening to Scott. For more information, see, are we on here? There we go. I was never the AV kid. So there's where you can download Scott's information. Follow him on Twitter as well. And he is just a terrific asset to Colorado State and to our state. So now, that's the science. We know it's simple, it's serious, it's solvable. So what do we do to move on to the next phase? How do we solve this? What can we do to stop lighting carbon on fire and advance to a new type of energy? And so for that, Chuck Kutcher from the University of Colorado, formerly with NREL, is here, and he was going to be talking about renewable and sustainable energy sources in the future. I've not had the pleasure of listening to Chuck speak in person before. I'm really looking forward to it. So Chuck, thank you so much for joining us.
Thanks very much, Mike. Can everybody hear me? Make sure this mic's working. Okay, great. All right, I am not going to try to reproduce Scott's molecule dance during my presentation. but I do hope to extend some of the things he said about solutions. So Scott mentioned that we have this imbalance going on, and I would, there's another way to look at it. So there's more solar radiation coming in now than there is infrared radiation going out, and that's because we've increased the carbon dioxide content of the atmosphere by 46%. That's a lot. And so the Earth is heating up. The amount of heat we're adding is equivalent to 500,000 Hiroshima bombs going off every day. That's how much heat we're adding to the atmosphere. That has consequences. So climate change is not something to worry about just for the future. It's happening now. The planet is warming, and it's also warming non-uniformly, and we're seeing all sorts of crazy things with the weather. So this is just some of the examples of the things that are happening now. The unrest, the civil unrest in Syria was preceded by a record 5-year drought. Many articles have made the connection with climate change. Colorado Springs, Waldo Canyon, enormous hot fire, June 2012. Many of you have seen what's happened with the bark beetles in Colorado, the number of trees that have died, hurricane damage, Great Barrier Reef. This is the Great Barrier Reef. This is Lizard Island, the north end of the Great Barrier Reef, March 2016. It's been estimated somewhere between 30 and 50% of the coral in the world has died, and up to 90% could be dead by mid-century. And 1 out of 4 marine species depend on coral reefs. So this is really serious stuff. And it has economic consequences. So for many years, if you looked at the big disaster events in the US, they would average about $50 billion a year. That's that black line along the bottom as you go through each month of the year, winds up being about $50 million. But the 6 highest cost years due to damage, due to these extreme weather events, have all occurred since 2004. 2017 set a record. $306 billion due to these extreme weather events. And you all saw what happened in California with the wildfires. This was a report that was done by AccuWeather. They added up all the costs of those wildfires. They estimated it would cost California $400 billion. So not addressing climate change has enormous economic consequences. So we need to think about future generations. And certainly this guy comes to mind, because really, what kind of a world are we going to leave for Keith Richards? So what do we have to do? You know, Scott sort of pointed to the main thing. Look, we have to stop burning stuff. We have to stop burning coal, oil, and natural gas. That's what's added all this carbon dioxide to the atmosphere. We know that. We've known it for a long time. It's pretty simple. So I think we really need to do 4 things. 1, we need to maximize energy efficiency. Energy efficiency is very, very low in cost. It creates lots of jobs. Electrify everything we can. Why do that? Because on the next line, wind and solar, as Scott pointed out, have gotten unbelievably inexpensive. Those are carbon-free sources. That gives us energy without putting carbon dioxide in the atmosphere. Let's use it, but to use it, we got to electrify. And then finally, when we have this solar and wind on the grid, those tend to be variable sources of electricity. So how can we control that? There's many ways to do it, but one of the ways to do it is to control when we demand electricity, and I'll talk about that. So first of all, maximize efficiency. Buildings are key. Again, Scott alluded to this. In the US, about 45% of US carbon emissions are due to buildings. So this is the main office building at the National Renewable Energy Laboratory. It's a research support facility. And this is an example of many of the different energy efficiency features that are used there. I won't go into all of them, but just to tell you that this building uses about half as much energy as the best building energy code that Scott had on his slide. To make it net zero, we need to have renewable energy on campus. And so this is the photovoltaic modules all around campus. I'll use another pointer here. I don't think this one's not very strong. So this is the building here. It has almost a megawatt of photovoltaics on it. There's over a megawatt on the main parking garage, and there's about half a megawatt on the visitor canopy. These three together are 2.5 megawatts, and those make this main office building, which houses about 1,300 people, net zero. That means on an annual basis, there's enough renewable energy produced on campus to make up for the energy use of the building. It's great to do net zero energy buildings. They're proliferating around the United States, but to address climate change, we can't do it one building at a time. And so we put a lot of effort into extending from net zero energy buildings to all electric zero carbon districts. There's about 7 in the US that are being worked on, and 3 of them are right here in Colorado: the National Western Center, Peña Station near the airport, and the Sun Valley neighborhood, the lowest income neighborhood in Denver, which is right along the Platte River. All right, electrify everything. So in Colorado, in many places, we heat our homes with natural gas. We're going to have to transition out of that, and the way to do it is to run electric heat pumps. What's a heat pump? It's an air conditioner that runs both directions. It cools your house in the summertime. It warms your house in the wintertime. These have gotten really, really efficient. This is a new article that was just out like 4 days ago, 6 days ago. And you can see here, they're making the point that these things even work in really cold climates now. These are Chevy Bolts. They're autonomous Chevy Bolts because General Motors sees a real market for electric vehicles going to fleets. If you own a fleet of vehicles, you want low maintenance costs. Electric vehicles have very low maintenance and also very low running costs. So how quickly can these kinds of transitions happen? These are 2 photographs of New York City. This is Fifth Avenue. It happens to be on Easter Sunday. On the left, 1900. On the right, 13 years later. On the left, all horse-drawn carriages. On the right, virtually all automobiles. Why? Automobiles just were a lot better than horse-drawn carriages. And in fact, how many of you have driven an electric vehicle? I think you know an electric vehicle just makes a lot more sense than a gas vehicle. So we're going to see that transition. So where are electric vehicles being sold? It turns out half the ones in the world are being sold in China. China is really taking the lead in renewable energy and electric vehicles, and we need to catch up. All right, produce electricity from wind and solar. Wind, we're talking about land-based and now offshore wind farms. That's off Block Island on the East Coast. It's 5 turbines. It's a 30-megawatt project. It's the first offshore wind project in the US, and there's more coming up. Solar photovoltaics, central, that utilities own, community solar that you can buy into, and also rooftop solar. We need it all. So again, and I think Scott made the point of how cheap PV has become. But here's the penetration. It's exponential growth. And actually, last year, in 2018, we passed a benchmark, 1 trillion watts combined from wind and solar. So the blue is the wind growth and the yellow is the solar growth. Just phenomenal growth. Why? Because they've gotten so cheap. Here's a good example. Recently, Xcel went out for bids for new electricity generation. The very low bids they got were from wind and solar with 4 hours of battery storage at between 2 and 4 cents per kilowatt hour. Does anybody know what the average retail cost of electricity in Denver is? Yes, it's 11 cents a kilowatt hour. That's how cheap renewables have become. Well, guess who's putting the most money into investing in renewable energy? China at about $2 billion a year. Europe is next with about $1.5 billion, and we're in 3rd place with $1 billion. According to the U.S. Bureau of Labor Statistics, the 2 fastest growing jobs in the United States, #1, solar PV installer, #2, wind turbine technician. And if you look at the chart, when you get to 3, 4, 5, these are all medical jobs like medical assistant and stuff. Much, much lower growth. These are the biggest, by far the biggest growth jobs. And salaries are between about $39,000 and $54,000 a year. So again, because renewables are variable, one way we can capture them, if the wind isn't blowing in one place, it's going to blow somewhere else. And so if we can spread it out, we can really make renewable energy smoother in terms of supply. And Sandy McDonald, Dr. McDonald, is going to talk about a high voltage DC transmission system and how important that is. So you'll learn more about that. All right, the last, control electricity demand, match renewable energy supply. Again, this is a buildings thing. Does anybody know how much electricity buildings use in the US? It's 75%, 3/4, all right? So at NREL, we've developed a home energy management system. And then I want to finish by reasons why I think 2019 is a year that we might finally see people take climate change seriously and treat it like the emergency it is. You've heard about the Green New Deal. That's Ed Markey on the right. Alexandria Ocasio-Cortez has been in the news a lot. I think this is very aspirational and inspirational. It's got a lot of people excited. It's just a resolution at this time, but I think it's waking people up and getting them moving in the right direction. This is Iowa, and this is just weeks ago, the flooding that occurred there. Well, guess what? The first caucuses are in Iowa, all right? I think people are tuned into climate change there. So we're going to see, this is going to be the first presidential election where climate change is really going to be a topic. How many of you have heard of Greta Thunberg? Terrific. She's 16 now. She was 15 years old when she was a lone student that went out and went on strike and said, look, why should I go to school if when I graduate, I don't have a world I can really function in? And that's spread all around the world, and we're seeing these student strikes throughout the US and around the world. Here she is meeting with Pope Francis just a couple days ago. And this reminded me of this quote by Margaret Mead. Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has. And so we're seeing this movement really grow. All right, so Scott talked about what great things we've done in our country. And I want to give you an example of what we can accomplish if we put our minds to it. World War II. This is a Ford Motor Company factory in Michigan. It produced automobiles. President Roosevelt said, no, you're not going to produce automobiles anymore. You're going to produce bombers. So they converted their line over to a B-24 bomber line. At the height of production, 1944, this factory produced one complete B-24 bomber every 63 minutes, 24 hours a day, 7 days a week. That's what this country can do if we put our minds to it. Imagine if we put this effort into producing wind power and solar power. Thanks very much.
Thank you so
Thanks,
much.
Mike.
Really great job. Chuck, thank you so much. Terrific job. Again, there's his contact information. So one of the pushbacks that I oftentimes get from viewers is, okay, I mean, we can do all this renewable, but as Chuck said, the sun doesn't always shine, the wind doesn't always blow. I usually respond to, you haven't spent a lot of time in Wyoming. But even if we are producing vast amounts of wind and solar in certain areas, we've got to figure out a way to efficiently move it around and get it to where it is being, the demand is from where the supply is. My next speaker is a longtime friend, the former president of the American Meteorological Society, so I'm in high company right here, and has spent many years working up a lot of research in Boulder. He's currently with a company called Spire, which perhaps if there's a minute you can quickly explain to people what Spire does, Sandy, and has an idea of a concept that would enable us to quickly and safely move energy across the country, satisfying the conservative and the more progressive person. So without further ado, Dr. Alexander Sandy McDonald.
So we've promised you solutions, and I've been fortunate to work in a laboratory where we really looked hard at how could you solve this problem. And I want to start with a fact. How much solar energy hits the United States right now? How does it compare with the electric energy we need? The answer is there's 50,000 times more solar energy hitting the United States from the sun than we need for our electricity. So there ought to be a way to use that. And being a lifelong weather person, I thought about this a lot, and I thought when I saw the Secretary of Energy about 12 years ago say, oh, wind and solar won't work, they're intermittent. And I thought about it, I thought, well, yeah, if you stand at a point, it's intermittent. But it's not intermittent for a larger area. All we really need to do is move it around. So there's all that energy. Scott said there are solutions, and I was fortunate to be in a laboratory at NOAA where we had huge amounts of weather data and really talented scientists, and we worked on it for a while, and we came up with something kind of simple that both Democrats and Republicans like. That is, if we could have a free market in the various types of energy, as you saw in Scott's graph, the cost of wind and solar has come down so much, they would win in a free market. But they aren't going to win the way they need to if we can't move the energy around. So I'm going to take you through this step by step and explain what the problem is now and how now, unlike in previous years, it is solvable. So what we want is a solution that will, first of all, be available now. I hear a lot of people talk about technologies that are going to be available in the 2030s or the 2040s. The way I characterize that is, let's let the next generation solve this problem. And I don't think that's fair, and I love the idea that every generation gets challenged, as Scott said. And our challenge right now is to solve this problem. And the argument that I'm making here is we have the technology right now to do it. The second thing is, you can't say, well, this is something that's so important, we'll double the cost of electricity. That politically is never going to work. And the third thing, you often hear, well, yeah, we do things in the United States, but it won't work anywhere else, and you know, the world is just going to be in trouble anyway, so why should we do something? But that's not true. The solution that I'm going to talk about, we really do have something that'll work everywhere. So we need to check this, and I'm going to kind of go through it. Let's start with something you've already seen. There has been amazing technology. $76 when Scott graduated from high school. I hate to say it, but he graduated a little after I did, so I could probably have an even bigger number. But as we look at this, what we see is that wind and solar are now below natural gas and way below coal. And this isn't my word for it. This is a company that very carefully looks at unsubsidized energy and tries to estimate what the cost if you build something new. So this is what they call levelized cost of energy, and the cheapest by far are wind and solar. So why aren't we using it? Okay, this really pretty chart, at least it's pretty to me who kind of loves meteorology, is showing the amount of wind energy available over the United States. And if you look closely, you can see all the river valleys and so on. The big message here is there's a huge amount of wind energy available. Those red areas particularly have a lot. But there's something interesting here, and that is if you look across the whole United States, we see all the red areas. Then we see some areas that are kind of across the southern United States that are kind of blue. But those are areas that have all the solar power. So there's a lot of solar and wind energy across the entire country. In fact, when you look at something I'm going to show you in a minute, it really kind of says this would be a jobs program where we do our own energy instead of asking Saudi Arabia and Venezuela and Russia to deliver us energy. If we built the wind and solar needed to run our economy the way we just heard about, it would be something that all the way across this country would be jobs that are here and can't go elsewhere. So I'm going to talk about a farmer in eastern Colorado. It's this gentleman right here. He's really happy that he got this wheat. I don't think he's noticed the combines are going to run him over. So he's also got very inexpensively a place to store it. And he's got a whole railroad network. In fact, he's got ships that'll carry grain to Egypt and everywhere. So he has a market. So the question is, why don't we have an electricity market? Well, that's something that we really worked on. And it's a little bit complicated, but I'm going to try and take you through it. And for starters here, we're going to think about what would happen if he set up a wind turbine. So there he went out in his wheat field and he put a wind turbine, and he figured out with the cost of the turbine and so on, he's going to make a lot of money, just like his wheat. But then he has a problem. I'm going to just jump back here. So his problem is that he'd have to store the energy, and he really can't transport it. And the reason he can't transport it is that the current network is what's called alternating current. So let's take a look at how we solve the intermittency problem for wind and solar. So this chart in motion, I'm giving you a preview here. Okay. So this chart in motion basically shows that at any given time, I'm showing you the amount of energy available at any given time. And these red areas and light-colored areas are areas where there's either wind power like here or solar power like here. And I'm going to let it run again. Okay, another preview. So what we have is that at any given time, there is either wind or solar power somewhere available. If we look at this right here, we see that a big part of the US has almost no power. Those are the blue areas, but part of it does. And when we looked at that chart in motion, what we could see is that, I'm going to come back here. So we'll watch it in motion. So there's always power somewhere, and those orange areas are areas where the sun is shining. The deep red areas are where the wind is blowing. I've given you lots of hints here. So what I'm going to talk about now is AC/DC. So what I did was alternating current and direct current. It turns out that we had a system that was built on alternating current because of what happened 100 years ago, where a gentleman by the name of Tesla argued with a gentleman by the name of Thomas Edison about what is the right answer. So I did what any good scientist does. I went to Google and I put in AC/DC. And I said to Mike, this is really a great picture. Let's have our speakers dress up as this, you know. And of course, we got into an argument who got to be the lead singer. So here's the real deal. These two gentlemen were trying to figure out what is going to work best, and they had the right answer. Tesla is the one who won. He said that alternating current power is the right answer for the 20th century. And the reason for that is a little bit complicated. It's mainly that you can change the voltage on it really easy with transformers. Direct current is the answer now that'll help us with the climate change issue. So that if you can have both, we keep our alternating current for our regular electric network, and we put in the 21st century equivalent of the interstate highway system. And interstate for electrons, that's electric current. So let's see a little bit about why that is. So here's an example of a network. It looks a lot like the interstate highway network. And it could be above ground, or like this one over here, or it could be below ground. The advantage of below ground is that it can protect us from solar storms and even these things called EMP bombs that can hurt the electric system. So if we were able to move the energy from wherever it's being produced to wherever it's needed, that would be an enabler that allows a huge amount of wind and solar energy. So how did we prove that? Well, we worked for 6 years in our laboratory. We basically looked at all the different types of energy and this network. And what we found was that you really don't get large amounts of wind and solar energy unless you have this network. It allows you to move it. And the trouble with alternating current is there's this thing called reactive power and keeping the grid in sync that doesn't allow you to move it very far. So there's an opportunity, not just in the United States, but elsewhere. Right now, the only country who's really working on this kind of a network is actually China. So we did this study. 6 of us worked for 6 years, and it basically showed that if we had done this, that it designed a network. It was a computer program that designed a network. We tested it in 2012, and it really gave the right answers. So what this shows is that it designs a network where there's wind and solar across the whole country. The green are where it would use wind. The black lines are the network that moves the energy around. These red dots are basically where we have solar plants. So it designed a network that was optimum for the wind and solar era. Here it is running. You can see the dark blue when the wind is being used. You can see the red as the sun comes up and goes down. So the study basically showed, using about 50 billion pieces of weather data, it showed us that we could operate about 60% on wind and solar, with the remainder other carbon-free plus natural gas in the study. So here's the actual numbers. It showed right now, or 2012, we were using about 2 billion tons of CO2 in the US. The clean power plan would lower us about 10%. But if we were able to use this national network, we could keep our costs, which are these little red dots, about 10 cents a kilowatt hour, but we would reduce our CO2 by 80%. So we have a system that's workable with today's technology, that doesn't increase your electric costs, and that can work globally right now. And I want to say one of my co-authors is here, Adam Dunbar, really terrific people at NOAA that I worked with. We talked to everybody, and what they said was, it's too big. You know, you might think there's Democrats and Republicans in Washington, but they're all part of the money party. You know, the people with the money call the shots. Well, in my opinion, this country has faced huge challenges before. They faced the challenge of slavery. They faced the challenge of World War II. You saw that. And President Lincoln, while they were working on the Civil War, while it was in progress, he was thinking about a transcontinental railroad. President Eisenhower, the leader at D-Day, he got into office and he said, we need a national interstate highway system. So I believe in this country. I believe that a future president is going to look at what can be done. And I hope it's soon, because we really don't have a lot of time. But I believe that there are technical ways right now to solve the kind of problems that are so great and that we face right now. So thank you.
Very exciting possibilities. I think this is it energizes me. This could be a real solution. And when I speak to the grade schools, I tell the kids that, the phones that we take for granted right now didn't exist 15 years ago, and they have the power of a supercomputer that filled a room 25 years ago. And so I tell these second and third and fourth graders that who knows what amazing things you're going to invent in the next 25 to 30 years. And then we have all of the teachers give these future world changers a round of applause, because I think that those kids are going to solve a lot of our problems. But we're going to have to get going on it sooner than later. So, the question is, the science, the physical science is pretty easy. The solutions, we have some. The hardest part seems to be the political science. And so we need to find somebody who has some experience at that. And we happen to have somebody here tonight, and that is the 41st governor of the state of Colorado, Mr. Bill Ritter, Jr. And Mr. Ritter will be speaking about the new energy economy and how do we get from where we've just shown you to where we need to be. So without further ado, once again, 41st Governor of Colorado, Bill Ritter, Jr.
Thank you. Thanks. I have to make sure my microphone is on. It is, isn't it? I borrowed it from Scott. I was going to have to stand behind the podium, but I do better out here. A couple of things. I actually do not talk from a PowerPoint, although those were excellent presentations, and I really do appreciate being a part of a panel of experts. I have been on a panel of a group from the National Academy of Scientists. And I told this story earlier tonight, where we were looking at how to accelerate the adoption of cleaner energy technologies. And we had a member of Congress say, do not recommend a price on Congress, because if you do, you'll be dead on arrival. And I said, are we the National Academy of Science or the National Academy of Political Science? Because the science and the politics in this have very much been in conflict for some time now. And it's really sort of sad that we as a country have allowed this to become, in some respects, a political wedge issue. I'm hopeful that it's becoming less and less and less of one, but there have been a lot of places around the country, not the least of which is Washington, D.C. So we talk about the intersection between policy and politics. But I'm going to broaden that intersection a little bit to say there's absolutely an intersection between politics and policy, technology, and finance. So think of a triangle. For us to do the things we need to do to really solve around the problems of how we change not just our electricity systems, but our transportation systems, and how we emit in the industrial world, industrial producers of emissions, and also in the agricultural sector. Those things are all part of the greenhouse gas problem that we're talking about tonight, and about climate change in general. And for us to think about how to solve that, we have to understand that it's not just public policy, it's policy plus innovation, which I call also technology, and how we finance the transition. Those are the things that are going to matter in terms of how we, as the United States of America, solve this. Let me just tell you a little bit about the work I've done since I left office as governor of Colorado. I went to Colorado State University, and for the past 8 years now, have worked with states, with utilities, with utility commissions on how we make what I call the clean energy transition, and really what kinds of policies drive that. And so I did do one year-long project for the President of the United States when it was President Obama, and we made recommendations to the White House about how to really try and drive a clean energy agenda at the federal level, particularly if Congress was not going to act. And so we did that, but the rest of our work has been with states. And I just want to come with a little bit of good news tonight. There's a lot of this that is a fairly gloomy picture, and they're right to state the problem in the way they have, and there are still a lot of barriers to it. But many of the barriers that we've experienced over the last several years, even the last couple of decades, I see kind of going away. I recognize a pivot that's been happening, and a pivot that's been happening over a period of time here in the United States. And let's talk about what some of those pivots have to do with. So I credit policy with that cost decline curve. If we had never put in place renewable energy standards in the United States of America, I don't know what the cost decline would have been, but it would not be 80 to 85% reductions in solar, 80% reductions in storage, and really like 65, 70% reductions in wind power. So when I became the governor of Colorado, there were only 275 megawatts of wind on the grid in Colorado. And we had no real policies that were trying to incentivize the build out of that. We had a production tax credit that was in place, but in Colorado there was not sort of a policy to do that. We put in place a renewable energy standard, and the voters did that. No politician did that. The voters of Colorado were the first state in the country to put that in place. And then I came into office and we doubled it, said it's going to be 20% by 2020, and then we tripled it by the end of my term and said it's going to be 30% by 2020. And the biggest utility in Colorado, Xcel Energy, 2 years ago put before the PUC an energy plan that said we're going to get to 30% by 2020 because we had to. Now, because of where the market is, we're going to 55% by 2025. Yeah, it's a really good thing. And there's a lot of people in this state that have worked really hard on that. But the important part of that story is that if we were still at 0% in an RPS, there was no mandate, then we would not have grown the market that allowed this economy of scale to really take over. And so there's this false argument that happens in the United States of America, and in part, it was a partisan argument where these people are talking about, government mandates. We need government regulation. We need this to happen. And another group of people saying, no, we need the market. We just need the free, pure market to control. Well, first of all, we've regulated energy since 1905 in this country, and so it's never been an unregulated market. There's always been regulation since we really understood sort of what this was going to look like. The production and consumption of energy had monopolistic tendencies for the producers, and for the consumers, they could very much become victims, and so we said, we're going to regulate that. That's number one. Number two, it's not an either or. What we've seen in terms of renewable energy in the United States of America is this mix of what happens when there are ways to incentivize the production and the consumption of one kind of energy, and in this case, let's just talk about renewables, and then how over time, when you build that out to scale, this economy of scale happens, and over time, the prices come down to such a place that they're cheaper than the kinds of fossil fuel energies that we've been used to producing and consuming by and large in this country for 150 years. So here we are now where we have states looking at this and saying, okay, so we did a lot with respect to state policy. What are the kinds of things we do beyond renewable portfolio standards? And there's a variety of those things. And interesting thing about the states, while this is still somewhat of a partisan conversation in Washington, D.C., and we can see it softening. We can see people on both sides of the aisle beginning to talk more to each other, and it's less partisan. At the state level, we've seen Republicans and Democrats alike embrace policies that have helped move their state to a different place in terms of clean energy consumption. So in the last several years, the Republican governors in places like Michigan and Illinois, Nevada, Massachusetts, Maryland, these states, all with Republican governors, some with Republican legislatures, have actually embraced clean energy policy in a pretty significant way. And so at the state level, there's a lot happening in this country that it doesn't necessarily dent some of the problems that we have in Washington, D.C., and particularly some of the things that the federal administration is doing now to try and carve back some of the successes from the prior administration. But there's a lot happening at the state level that's making a real difference. And even in November, there were 9 different gubernatorial candidates who campaigned on 100% renewable. Now there's a question, how soon can you get to 100% renewable? How can you get there in an affordable way? But the fact of the matter is, I think very much as Chuck was saying, this changed the conversation, right? There are people who are campaigning on this openly about that, saying we can get to 100% renewable. But it's not just the electricity sector that we need to worry about. And in fact, in the United States of America, 2 years ago, the carbon emissions from the electricity sector, the power sector, have been going down, and they were eclipsed by the transportation sector. First time since the 1970s where the transportation sector was emitting more carbon than the electricity sector. And we see some downward trends. We see positive downward trends. We have to maintain that, and we have to accelerate it if possible. But we have to pay attention to the transportation sector and how we get to the place where we reduce emissions in the transportation sector. And that's going to be the same thing. It will be a mix of policy and markets. Now, there's more that the federal government can do actually to inhibit the emissions issues, the policy issues that states are trying to do. A lot of this is about a federal program, CAFE standards, which are fuel economy standards. The Obama administration said, well, by 2025 or 2026, fleets have to get to 55 or 56 miles per gallon on average across their fleet. And the Trump administration has said, well, we're going to hold everything at 2020, and we're going to carve back what we had once said as a country we were going to do. There are 14 states that said we fully embrace those economy standards for 2025, and we're going forward, and now there are going to be lawsuits to decide, does the federal government control that? Can states go beyond where the feds are? And that's an important part of the transportation policy exercise that's happening. And there's all sorts of policies. There's low carbon fuel standards. There are zero emission vehicle standards, lower emission vehicle standards, all of which states can play a role in, but the federal policy could come in and inhibit the states being able to do that. And this transportation sector in the United States is so important. Here in Colorado, carbon emissions from the electricity sector are still more than the transportation sector. And so there's absolutely no doubt that we need to work on this. We need to work in a significant way. It is important to think about the politics here. And what I would say, and it's probably easier for me to say because I'm not a candidate for anything, we have to have both sides of the aisle on this. We have to be able to work and talk with Republicans and Democrats alike. And that's why I like this state work, because there are many places where we've been able to do that. I run a National Legislators Academy out of Colorado State University. So we bring legislators from across the nation in for this Clean Energy Academy, and we insist on having Republicans there and Democrats as well. And they just passed pretty significant legislation in a variety of states just into the 2019 legislative session, where some alum from our legislative academy, Republicans and Democrats alike, are sponsoring those kinds of bills that are helping move that policy at the state level. Before I sit down, I want to say a couple things about what cities are doing and about what the private sector is doing. Cities are moving on this, cities and counties across the United States. So while the states have done a variety of pretty big and important things across the United States, there's a variety of places where cities have said, you know what, this is too important for us as well. And we're not going to sit back and wait for the state to act, or we think we could be part of state action, or we just think that it's important to our constituents and we just may not be getting all the attention that we need. So across the United States, cities are doing really important things. And here tonight in Denver, the city council is debating part of their climate action plan. And one of the things that all of us should do who care about this issue is think about, how do we support people at every level of government, local, state, and federal alike, to ensure that they have the focus that they really need to have in order for policy to be part of the conversation about how to move a clean energy agenda, and I would argue how to do it reliably and how to do it affordably. That's all part of the conversation, because you can build a clean energy agenda on the backs of really poor people. And you don't want to do that. We don't want to do that. We don't want to have a clean energy system that's too expensive for people in this country and in this society, and really, I would argue, around the globe. The second thing is, there's a lot of places where private sector companies have said, we're not waiting either. And in some places, they've actually exited their utility. They paid to exit their utility for the non-depreciated costs and said, we're getting out. So the biggest gaming company in the world, MGM, said, we're not going to wait for NV Energy in Nevada to actually get to the place where they're producing enough renewable energy in their portfolio. We're exiting, and we're going to buy on the independent power market. We're going to pay millions of dollars to get out from under this utility, but we're going to buy on the independent market, and we're going to make a commitment to 100% renewable over time. And there's a variety of companies. There's a big group of companies, some of the biggest corporations in the globe, called RE100, that have made 100% renewable energy commitments. It's really another important thing to pay attention to, because that's the private sector acting without policy levers, making sort of the push. They realize the benefit of it, both from a corporate social responsibility, but also from a cost perspective, from just a pure business analysis. It makes so much sense. And the final thing I'll say, this really is the final thing, is that we believe there is this energy transition happening. And the speed at which it happens is really something that's important. Markets, again, are helpful here. We're watching markets do really important things. But the speed of that transition is not necessarily going to be decided by markets alone. And there has to be, I would say, a political activism in the United States and around the globe that ensures that if the markets are acting too slow to address this problem, that policymakers are informed about how much we care about this. And we care about this transition, we care about decarbonization, but we also should care about people who are going to be left behind. Because there are absolutely winners and losers in the transition. And if you look at what's happening in coal communities around the United States, they are being left behind already. You know, the Trump administration talked a lot about resuscitating coal. It's not happening. There is not only not new coal being built, mostly it's just being shut down. At my center at CSU, we've looked at the western United States. 45% of all the coal that existed in 2017 will be gone in a decade in the western United States, and the other, we would say another 40 to 45% will be gone in the following 7 to 10 years. That's precipitous. 90% of all the coal in the western United States. Now, what we replace it with is really an important question for climate change, but how we treat those communities and what's sort of the just result for those communities is also a part of the conversation about transition. Thank you.
You can stay right here, Bill, because
Okay.
we're going to have to. Thank you very much, Governor Ritter. If our other three panelists would come down, we're going to have a seat here. We'll bring the house lights up a little bit. And we have been, everybody say hello to Sarah over here. Sarah's our photographer from Denver 7. We've been streaming this online, so it's also been seen all over the world. And not just here with 400 people. So we're going to take some questions from the audience. We have a few minutes here to take some questions, some comments. I'll also be monitoring from the TV station. Our digital folks will let me know if there's some folks online that want to ask a couple of questions as well. So first of all, can we just give these gentlemen a nice round of applause? I'm on. There we go. So why don't we start? If we don't have a microphone to pass around, because if we pass the phone, then back. So hi, would you speak up nice and loud, and I'll repeat your question or comment?
Thank you so much for presenting this, for your wise words. Bill Ritter said something about political activism. What are the names of bills? HR 763, that's the House bill about energy innovation. What are some other bills that we can be calling our Congress?
So the question was, what are some other bills, Bill, that we can?
So I don't know numbers, and I actually don't pay as much attention to what Congress is doing because of how difficult it's been to get anything passed in Congress. And so I would just encourage you to call your own representative. Let's start with the state first, though. There's a variety of climate stuff happening at the state level. And right now there is a climate bill. I think it's referred to as the climate bill. It looks at setting carbon limits. That bill number, I think, is 1260, I think, is the number of it. It's a bill where Casey Becker, the Speaker of the House, has sponsored it, and it sets a target for us to reduce our emissions economy-wide by 50% by 2030. That's a really ambitious target. And it gives the Air Quality Control Commission the ability to go in and set rules that will, I think, inform us about what kind of progress we're making toward that. We get a readout every couple of years, and I think there's people thinking that's a lot of power for the Air Quality Control Commission. I think they'll probably do some stakeholder work, but that's an important starting point for us as a state right now. We don't have emissions reduction goals set. Other states have done cap and trade, or the regional greenhouse gas initiatives done that. So it's a good thing for a state to be in the business of carbon. I would also, and this is just a commercial for Xcel probably in some respects, but seeing what they're doing, Xcel has an ambition to cut their emissions by 80% by 2030, 100% by 2050. There's no other major utility in America that's been as bold with that, and they have a bill that they're trying to pass that will give really the Public Utility Commission the ability to regulate them to that goal. So they're portfolio has to match that 80% reduction from their 2005 number. I would say that's a pretty important thing. And then there's a bill that involves the Public Utility Commission, and it says for their resource planning, they have to take into account the cost of carbon. Not something that they're required to do, especially the way that it's required in this bill. And while we're not going to expand the renewable portfolio standard this year, and maybe not ever, the governor is against sort of top-down mandates, the social cost of carbon inside resource planning is a really elegant way for us in Colorado to get at this question about carbon emissions.
Thank you very much, Governor Ritter. I did get a note that there is an app called Countable that tells you all the bills for your state, city, and such. Thank you to my wife, Cindy, for pointing that out. Over here, yes. Who'd like to take a shot at that one? Chuck?
Yeah, sure, I'll do that.
Did everybody hear the question? The question was, what about the birds and the bats in terms of renewable energy?
So when wind first got started in this country, there was a large wind farm built in Tehachapi in California, and bird kill was a serious problem. And the wind industry really learned a lot from that. One thing they did is they made wind turbine towers now so that birds can't perch on them. But even more importantly, they did extensive studies of bird migratory paths. And so as a result of that work, a bird kill, a bat kill has gone way down. You've probably seen the statistics, how many birds get killed by cats and flying into buildings, that sort of thing. Wind power is far down that list. But it's because the wind industry really listened and really did their studies. And so now the Audubon Society basically endorses wind power because they realize that climate change is going to kill birds. And if we could prevent climate change, actually it's going to be better for the bird population. There's also, it can be an issue with concentrating solar power. And the concentrating solar power industry has been also doing the same thing, looking at ways to prevent birds from landing on collectors or flying by towers where there's concentrated sunlight. They've changed the way they bring sunlight onto a power tower, for example, in order not to kill birds. So there's a lot of work being done on that. The industry is very serious about addressing it.
Very good. Yes, we have two gentlemen over here. You guys know each other? Okay. Why don't we go you first, then we'll get you afterward. Yes.
I'd like to hear reflections on developing a culture of personal responsibility and efficiency so that the demand side isn't very
Okay. The comment was about developing a culture on the demand side, because that is the conservation is the low-hanging fruit. Scott, do you want to?
Sure. Thank you for that. That's a great point. So all of us in our private lives have a tremendous amount of control on the energy that we use and to somewhat control on the source of the energy that we get. You know, so for example, my wife and I have long bought wind power at a premium, which is kind of maybe not everybody wants to do that or can do that. I think about stuff, I mean, some of this stuff is really simple, right? My mother told me to turn off the water when I'm brushing my teeth. She told me to turn off the lights when I leave a room. And, you know, we should ride our bikes to work and we should turn down the thermostats in the wintertime and things like that. I want to say something here because as important as that is, and it really, really is important for all of us, it's not enough. Okay, so this is probably not what you wanted me to say, but I'm going to say it anyway. Yes, it's necessary, and we all ought to do our part, and we have to do more than that, because if all of us were to cut our emissions by 50%, and the rest of the world came up to that 50% where we are today, the emissions in the world would grow dramatically. Not just a little, but increase by like a factor of 4. So in order to get to where we need to be, which is more like nothing being set on fire, no coal, oil, or gas, sometime in the next 20 years or so, it's going to take more than turning down your thermostat, recycling, riding your bike to work. Yes, you should recycle. Yes, you should ride your bike to work. And you should talk to each other. And you should vote. And you should push for the kind of stuff that we heard here tonight, policy solutions, grid solutions, renewable energy generation solutions that can scale up very rapidly to the whole world. So I absolutely agree with the gentleman that we all need to do our part, and we got to go beyond just our part. It's a big world out here.
Can I add to that?
Sure.
Please applaud. He's So the other thing I would say, I would endorse all that you said, Scott, and I would add to it, though, that we've modeled the cost of the transition. So I was a convener for 13 states. So there were 8 Republican governors, 5 Democratic governors, all of the West, Pacific Northwest, California, North Dakota, South Dakota. So we modeled all the ways to get to the carbon reduction targets required by the Clean Power Plan. And then all the states were on board us doing that. By far the cheapest way to reduce your emissions were energy efficiency and energy conservation, both at the industrial level and the residential level. And it's not enough, but if you wanted to start with the cheapest thing first, it would have been energy efficiency and energy conservation. The Supreme Court stayed the effect of the Clean Power Plan, and now the Trump administration's pulling back on it. They're going to have their own new Clean Power Plan that'll be a part of it, but we are going to probably get to that emissions reduction contemplated by the Clean Power Plan in the United States and even beyond in the power sector. And so it's a personal responsibility that has not to do just with how you consume energy, but also about transportation and also about, industrial polluters and ag and the methane release from ag production. It's about all of that, but particularly what we drive and how we consume at home are some of the easiest ways for us to have a corporate or have a personal responsibility around the subject.
Go ahead, Sandy.
We have in the United States and other developed countries about 3 billion people, and it's very important that we work on reducing our CO2. But right now there's another 3 billion who the only way they're going to get an advanced economy is the way we did it, by burning things. And there's those 3 billion right now, and by 2070 and 2080, there's another 3 billion with population growth. So one great thing that United States and developed countries can do is show the world how you can run an advanced economy without burning things. Take leadership. One tiny example, when the United States mandated catalytic converters in cars, they thought we were just doing it for us, but it ended up worldwide. We need to take that leadership if we're going to solve the problem globally.
Thanks, Andy. And on that last, one more from Chuck, real quick.
I'd like to add something about energy efficiency. One of the really great success stories in this country in terms of energy is appliance efficiency standards. And whether it's your washer, your dryer, your refrigerator, they are so much more energy efficient than they were. The refrigerator is a classic example. If you compare today's refrigerator to one back in the 1970s, it uses 1/5 the energy, it costs less, and it's a little bit bigger. So there was really no sacrifice in getting industry, giving them the incentive to make these things more efficient. But that's really been a success story across the board.
Thank you. And you had a question, sir, right here.
So in his book, Hot, Flat, and Crowded, Stephen talked about the fact that the energy grid is actually very regionalized and not national in nature at all, to the point where it's
talk about the energy grid. Sandy, why don't you go with that?
Really appreciate that question. I had a little trouble with my slides, but it's true now that our current energy grid is very limited. You can move energy on AC power a few hundred miles, but you need to move it over larger areas because larger areas are the size of the weather. So if you want to have your power coming from wherever there's a lot of wind or solar energy, we need that larger scale grid. And I'll mention something that we tested this idea for the United States, for Europe, for China, and Tom Friedman's book hits it just right. We have to have a solution that allows us to use wind and solar much more than we do now, and the regionalization of electric energy is one of the big problems we have to solve.
Thank you. We haven't heard from way up in the back. I see somebody waving. Yes, would you stand up nice and loud so we can hear you up front? Who'd like to address that one? Chuck?
I'll certainly address it.
Talk about nuclear power and that as a solution as well.
So I want to start by saying something very positive about nuclear power and then express some concerns that some people have. So first of all, there's 99 operating reactors in the United States. And they operate at capacity factors of greater than 90%, like 92%. That's extraordinarily good for electric generating systems. That means that basically their average power output is 92% of their peak power output. So thank goodness we have nuclear power. It saves an awful lot of carbon emissions in the United States. The problem with nuclear power is to build new ones. There's two real problems. One, they are very expensive. So there are several new nuclear power plants that have gotten almost halfway or more through construction. Construction has been halted because the cost overruns have just been enormous. So basically nuclear power in terms of cents per kilowatt hour is almost 4 times as expensive as solar and wind. So when you're talking about developing further power, it's hard to make the case for nuclear because it's expensive and also very, very long lead times. Even China is finding this. As China is putting in nuclear power, but they're finding that wind and solar gets online much, much faster. So those are the issues of new nuclear power. There are some new concepts, SMRs, small modular reactors. We'll have to see what they cost, but the fact is they'd have to come way down in cost from light water reactors to be competitive. The fact is wind and solar have gotten so cheap, and even for somebody like myself that's worked in renewable energy for 40 years, we've been taken by surprise. And a lot of it has to do with what Governor Ritter said. It's what are called learning curves. As we've deployed all this, people have learned ways to make it cheaper and cheaper. But I would say that there are people arguing to shut down our existing nuclear power plants. I think that's a mistake because whenever you shut down a nuclear power plant, carbon emissions go up. And until we're ready to replace all that nuclear with wind and solar, I think it's a mistake to do that because climate change is really an existential crisis. Nuclear power is not an existential crisis. And so we have to do everything we can to avoid adding more carbon dioxide to the atmosphere.
So just back to the, sorry, I keep. So back to the policy intersection here. Illinois and New York both made conscious decisions to keep their current nuclear fleet in place. It's more expensive. They're going to have to subsidize it. That means they're not going to replace it with combined cycle natural gas, and so they get the carbon emissions benefit of that. Other states have made different choices. California's made a choice really to shut down Diablo Canyon, and so there is a political issue, a policy issue that is in large part political. There's certainly the cost issue, and then there is what I call the social license to store or transport, because every nuclear fuel rod in the United States, spent rod, is stored at the location where it was used. And so we built Yucca Mountain. We have 0 spent rods there. And I know as the governor of Colorado, there are certainly people who would lay across I-70 if ever an 18-wheeler was going to travel across I-70 with spent rods in it. So in addition to sort of the cost problem, I think there's still some other social license to transport issues with nuclear. And I think that it's one of these tests that we'll see that's a political test state by state by state.
If I'm not mistaken, I think there was an article in the New York Times just today, a commentary about not shutting down existing nuclear, realizing that building new takes a long time, but keeping the existing running as opposed to replacing with something that puts carbon dioxide in the atmosphere.
So when they announced the Clean Power Plan draft, you could not have began permitting new nuclear and get it put in place in most states because of the federal permitting process and the testing process by the time you had to reduce your emissions. You couldn't rely upon it.
And of course, I think all of it, I'm talking to all these gentlemen off camera, if you will, I think we all have our levels of support for nuclear, of which I do as well. And then there's always fusion, which is, what's the joke? It's always 25 years away. But, should we be doing more to develop the research on that? That's the ultimate power supply. We're going to do one more way up in the back, nice and loud so we can hear you. This is part of what I was hoping tonight, is to give, if you just go with the doom and gloom, which Scott mercifully kind of went over quickly, that shuts people down, because you can't just talk about the negative. I think that's where you have to go and say, look at the amazing things that have happened in our lifetimes, and things that 15 years ago didn't exist that we take for granted right now, or 30 years ago. Think about the things you were worried about 30 years ago, that now it's a whole different world, and that is going to change, but we need to try and inspire people to be that change. And I'd said for a while that maybe I should run for office, and somebody said, he's a weatherman, he's been lying to you all these years, maybe that doesn't matter anymore, I don't know. But what occurred to me, and I speak for all of the people on the panel, which we're all locally grown. We're all along here in the Front Range. I did get a little pushback as I had the pictures up on the museum website saying, awful lot of old white guys on that panel.
This is true.
Yeah, but next year we'll try and have a little more of a diverse crop. But I said to my daughter, who's in the audience tonight, I said, you're the one that should be running for office, not me, because they don't need to hear from a 60-something old man. They need to hear from a 35-year-old that's got new ideas. So I think that may be where we end up going. Tiana's not going to stand up and say, I'm announcing my candidacy. But thank you for that comment, and I do hope that we're going to inspire. And I really do think that this generation coming up is going to say, enough of this. Let's get some solutions. Now, right here, yes, hi. Would you stand up, please? Can we shed a little more light on the efficiencies of direct current?
Yeah, so the problem is not so much direct current, which you can really move long distance. The problem is alternating current, which has two big problems. One of them is there's this thing called reactive power, where if you try and move it more than a few hundred miles, it's like a big capacitor, the line, and it pushes back. So there's a real difficulty with that. And there's another thing. We know that alternating current, it alternates, and it's over a long period, over a long distance, like more than a few hundred miles, those sine waves get out of sync with each other. So you have what are called balancing areas where everything is on the same thing. So the trouble really is, and this is Edison's argument, the trouble with alternating current is you can't run it very far. Direct current you can run for 1,000 miles with suitable associated electronics. So The advantage of direct current is we could make a national network, and we really did not have that capability until about 20 years ago when we made big advances in direct current.
And one of the things that Sandy has pointed out, and he did mention in his talk, is that if you bury that direct current line underground, it shields it from the effect of an EMP or from a solar flare that could not knock out the electrical power for a couple of days or weeks, but we're talking months, if not years, because these transformers have to be built, and we'd blow up. We'd basically put our society back to the 19th century, except that it'd be worse than that. If you ever search the Carrington event on the solar flare back in the 1800s, you'll see what it did to the telegraph. Kind of middle row up here. Nope, you're looking back now. It's you. Hi, yeah. Scott, this is right in your wheelhouse. The climate's always changed. Why is it different now?
Yeah, so absolutely, the climate has always changed. In fact, we know from looking at climate change over millions, even billions of years, that the only way climate changes is when more heat comes in than goes out, or vice versa, right? The Earth gets cold during ice age when more heat goes out than comes in. Not only that, we can measure how much extra heat it takes to make how much climate change by looking at all these times climate has changed in the past. Maybe you've heard of the Little Ice Age. There was a Little Ice Age, it was colder from 1400 to 1800. The amount of extra heat out minus heat in from the Little Ice Age is about 20% of the amount that our sort of plan A is to put in to the world in this century. So it's actually by looking at those past climate changes that we can measure how sensitive the world is to change. If climate has changed in the past, that proves climate can change, right? That if you push on it a certain amount with a certain number of watts, it warms up by a certain number of degrees. And those changes that we see in the past are completely 100% consistent with what we're seeing today. We know how many watts from the CO2, from the methane, from all these other things, and we can use those climate changes of the past to understand how much climate will change in the future. There's no contradiction at all between climate changing in the past and climate changing in the future. When somebody says climate has changed in the past, therefore it can never change in the future, you should look at them. And what are you talking about?
Another point on that is people will say to me, well, we only have 150 years of records. I mean, how do you know? And my response to that oftentimes is, how do you think they know where to drill for oil? I think they just go out there and say, that looks like a good spot. No, we are very good at, by proxy, figuring out the past and figuring out where those formations might be. Scott and his crew are very, very good, and all of the climate scientists are extremely clever at, by proxy, figuring out what the climate was and why it was that way going back hundreds of thousands, even millions of years. Chuck?
Yeah, I'd like to add just a little bit to what Scott said. Our species, Homo sapiens, has been around this planet for, and anthropologists argue when we really became Homo sapiens, but somewhere between 150,000 and 250,000 years. That's how long we've been on the planet. But it's only in the last 10,000 years. Agriculture developed, permanent cities developed, civilization developed. Why is that? Well, we came out of the last glacial period, okay, and sea level came way up, and then we hit this very stable period of temperature. So the Holocene, the last 10,000 years or so, has been an unusually stable climate. It's varied by plus or minus 1 degree Fahrenheit, okay? Under the George W. Bush administration, they hired, he hired someone to head NASA. In an interview, the guy at NASA said, well, who's to say today's climate is the best? It's the best because it's the one that all life on the planet has adapted to over the last 10,000 years, and we're blowing ourselves out of that. We've already raised it about almost 2 degrees Fahrenheit. That's the problem. It doesn't matter that climate change went up and down in the past. It matters that we're taking ourselves out of this wonderful Goldilocks climate. We're the ones who are screwing it up.
Sandy?
Comment when people say, well, it was a lot hotter in the past. When it was a lot hotter, the sea level was about 200 feet higher. So, in fact, 70 million years ago, the inland sea lapped right up against the Denver Front Range area. So those people who say, well, it was a lot hotter and things were great then, you might say, yeah, you were underwater.
But we did have a beach then. That was. Let's go right here. Yes.
Most recent IPCC report out of the United Nations says that we have 10 years to radically turn it around. Now, 10 years, most people here are going to be living for the next 10 years. And we're Americans with a lot of power. Most of us are white people, so we have lots of power. And so how is it that we organize or make the changes in 10 years that we need to make? I mean, we can't just wait for markets to rumble along. How are we going to do this in 10 years?
Bill?
So the IPCC report said to hold it at 1.5 degrees Celsius, the rise, we needed to make those changes in a 10-year period, and that becomes sort of the organizing principle for the Green New Deal. And, you know, there's a lot of pushback in Washington, D.C. About that. There's certainly pushback in various places around the United States, and there's a lot of places around the globe that aren't prepared to make that transition. And so you have to get people to understand the intersection between policy and politics, and we have to have a political system that's willing to respond. We don't currently have a political system that's willing to respond to that kind of ambition. We probably have a lot of other kinds of issues beyond policy and politics about that kind of dramatic change in a 10-year period. There's a lot of people that say we don't have anything close to the technologies available to allow us to get to sort of a net zero by 2030. There's a lot of folks out there that are looking at net zero by 2040 and say we're going to have to accept the consequences of not getting there by 2030. The climate change is already here. It's already real. And in order to adopt, we have to give ourselves another 10 years because we don't have a sense today about how to make that transition by 2030. But if you look at that picture, the two pictures they put up between, 1905 and 1913 or whatever the two dates were, there was a big transition that happened. And in order to move in a dramatic fashion, you have to begin to move today. And that's all I'll tell you, because I actually don't know the answer to your question about how to get to where we need to get to by 2030. All I can tell you is we cannot today delay the next phase of this.
Did you have something you wanted to add on that?
I want to say something to this too, because just to put that a little more clearly, the calculation is not that everything is fine for 10 years and then you fall off a cliff and it's the end of the world. Okay? Rather, you have to get on the path by 2030 in order to get to zero by more like 2035 or 2040. Which is hard, right? I mean, no sugarcoating that. That's hard. But let's get this straight. It will never be too late. You are not screwed if you don't do this by 2030, and you might as well just hang it up and go home. This will be something that we will work on the rest of our lives.
Yeah, go ahead. And now, Chuck, if you would.
I guess one thing I'd like to say is I think we have to talk more about climate change, have events like this, and also we need to get the facts out. And I think one of the most important facts is every study has shown that the cost of addressing climate change is less than 1/10 the cost of not addressing it. So every day that goes by, every day, it's costing us more to clean up from the wildfires, the record hurricanes, the droughts. You know, I started my presentation by showing you some of the things that have happened around the world. Those have very high cost tags associated with them. So the fact is, every day that we delay, it's costing us. So some people say we can't afford to address climate change, and the response to that is we can't afford not to. We have to address it. The other thing that I would say is, as a baby boomer, I have to be honest, my generation has failed to address this problem. In 2018, the world carbon emissions were higher than in 2017. That's despite all the solar and wind we put on the grid. We actually burn more fossil fuels, going in the wrong direction. And that's why I think we have to look toward these youth, and we have to help them. We have to encourage them, because they're saying, you guys screwed up. You're leaving us with an unlivable planet, and we're not going to stand for it. And so when you see students out striking from school, holding up placards, support them. They need our support because we have failed them, and they're trying to make up for what we haven't done.
Yeah. Yes, go ahead. You've got a nice big voice, too, so stand up so everybody can hear you.
Okay, you guys have to come up with a better answer. And what I would say is we figure out how we're expelling greenhouse gases, and we stop doing it.
But you said how.
And we stop doing it. And so we begin to organize. We find ways of working with different issues. And as we do that in small places, other people will see how we're doing it, and they will pick up on it.
I do hope that, from my experience of growing up in the 1960s with the space age and seeing scientists not denigrated but venerated, that they were the world changers and they were rock stars and superheroes, that we need to get back to that, where we look to our scientists and say they don't have an ulterior motive, they're just doing the science, and we listen to their wisdom and solve some of the problems. So I hope the 1960s and the 2020s perhaps are much the same in terms of what we accomplish in that decade. And we're going to finish up. I have a whole bunch of people that really like this guy. So we're getting a little late. We appreciate everybody hanging there. This better be really good, sir, because you might be our send-off. Wow, that's great. That's great. There you go. We like the power of insolation, which gives us solar power, and the power of insulation, which keeps it back in the house. Ladies and gentlemen, thank you so much for sharing an evening with us on Earth Day. I'd like to thank all of our panel here.